Alright, let's go over the fifth example of transformation of function with the given function of cosine of x. So as usual, when we complete the one transformation at a time for these three transformations, we want to use the order of operation PEMDA. So we're going to start out with the parentheses first. So let's say we want to put it here. Okay. So for the parentheses, let's say we have translating 2 units down, vertically stretching by a factor of 3/2 and reflecting about the x-axis. Well, inside of parentheses is the horizontal translation, either to the left or to the right, but since we don't have any horizontal translation, so we only have x inside the parentheses. Okay, and I'll get rid of this for now. So we'll have cosine of x. Now, so we are done with the parentheses. Exponent, we don't have any. Multiplication, we do, because we are stretching the function vertically by a factor of 3/2. So multiply by 3/2 right here. That's one done, but then we're not done with multiplication yet because we're also reflecting the function vertically across the x-axis. So we have to multiply this whole thing by the minus sign on the front. And the last transformation is shifting 2 units down. So that means we're going to have this whole thing subtract 2. With all transformation done, the function that represents all of our transformation is f of x equal the product of -3/2 and cosine of x, and all of it subtract 2. So how do we graph this? Well, when we graph the transformation of function, we want to graph the parent function first. So the parent function is cosine of x. And, you know, I'm not going to go, with pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, like in my video where I do the side function, but you guys are more than welcome to if you guys feel more comfortable with that. But anyway, for the parent function cosine of x, we are going to start out with x being 0. If x is 0, cosine of 0 is going to be 1. So right here. If x is pi over 2, then cosine of pi over 2 is going to be 0. So without here, when x is pi, cosine of pi is going to be -1. So maybe it's right there. When x is pi over 2, cosine of pi over 2 is going to be 0. When x is 2 pi, cosine of 2 pi is back to +1. So this right here is just part of the graph of the parent function. And again, this is graphing on the blank paper, so it's just going to be a rough sketch. So I do apologize if it doesn't look as exact as you expect. Now to go to sketch the other half, you basically just go the opposite direction. Just like a mirror image of this over here. But if you're not sure, just do plug and chuck again. So, well, x equals 0, cosine is going to be +1. Well, let's say when x is -pi over 2, cosine of -pi/2 is 0. So right there. When x is -pi, cosine of -pi is -1. When x is -3 pi over 2, cosine of -3 pi over 2 is 0. When x is -2 pi, cosine of -2 pi is back to +1. Like that. So hopefully I'm eyeballing it correctly. Yeah. And then just connect the points. Yeah, something like that. Okay. So this right here is the graph of the parent function cosine of x. Now, fun fact, every time we have a trig function by itself, it is actually multiplying by the invisible +1 on the front. And this number on the front here is called the amplitude of the trig function. So cosine of x has the amplitude of +1, and the amplitude is just half of the distance between the highest y value and the lowest y values. So the amplitude +1 of this cosine function is just half of the distance of it's just half of the distance between the highest y value positive 1 and the lowest y value negative 1. So we're talking about this half. Okay. Now let's graph the first transformation, which is let's see, inside of parentheses we don't have anything. So the first transformation that we are going to graph is vertically stretched by a factor of 3/2. Well, to do that, we take the most recent graph, which is the graph of the parent function here. And since we are stretching it by a factor of 3/2, basically we are going to take this whole graph and we just stretch it up until the highest point hits 3/2 and the lowest point hits negative 3/2. So let's say, so we have the highest point here, so with the vertical stretch by a factor of 3/2 is going to end up here. And the lowest point, let's say lowest point is going to end up down here. And of course this one is going to end up at the same spot like this one. So it over like that. Okay, and same thing for this one. This one got stretched down. And of course this one gets stretched up like that. And yeah, and we just connect the blue points. So let's say, and of course another fun fact is that when we take the most recent graph, which is the graph of the parent function of cosine of x, all of the points on the x-axis of the most recent graph is going to be the point of intersection between the most recent graph and the graph that you're doing right now. So these points here, 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 and here will be the point of intersection between the blue graph and this graph. So if I connect them, let's see, this is going to go this way like that. So we just keep going just like that, and then we go down, hit this, go back up, hit that, and we keep going like that. Okay, so the blue graph is the graph of 3/2 times cosine of x. So that's the second transformation. I mean the first transformation done. The second transformation is reflection across the x-axis. So we take the most recent graph, which is the one in the blue that we just sketched, and we just flip it vertically to, to make the graph of the vertical reflection about the x-axis. Okay, so to make it a little more clear right here. Sorry about that. So what is the graph of the vertical reflection across the x-axis going to look like? Well, that means all we have to do is that we take each of these points and we make a vertical mirror image of that. So for the highest point, if it's here, then it's going to end up down here. So this point end up here. The lowest point from here is going to end up where the highest point of the most recent graph is at. So this point will end up right here. Hopefully I did it correctly. Yeah. And of course this point end up all the way down here. Yeah. And this point end up here. Of course, down here. Yeah. And again, all of the points on the x-axis of the blue graph will be the points of intersection between the blue graph and the green graph that we are stretching in a bit. So just connect them. So we connect this through that, you see? And we just go down. And we go up again through that point of intersection. Alright, sorry for my bad graph. And of course, this one right here is going to go like that. Yep. So with that being said, this green graph here is the graph of negative 3/2 times cosine of x. And lastly, taking the most recent graph in the green, we are going to graph the last transformation of translating downward by 2 units, which will be in the red. So taking the green graph, to graph the translation of going downward by 2 units, we basically take the whole green graph and we shift everything down by 2. So let's say, probably we need some more points here. But let's start with the highest point first. So we're at positive 3/2. So if we move down once, we're going to end up at 1/2. That. And we move down once more, we're going to end up at negative 1/2. So I'll put it right here. Okay. So this highest point, when translated down by 2 units, will end up right here. And same thing for this highest point. Okay. For the lowest points, let's say this one, if we move down once, we're going to end up at negative 5/2. If we move down once more, we're going to end up at, let's see, this is negative 7/2. Right? So this lowest point will end up right here. And of course, same thing for here. So yeah, let's see, it's right there. And this one, same thing, end up right there. All right, and just connect the red dots. So let's say, where is it? I just saw it. Okay, there we go. So we're gonna have this. Yeah, so hopefully you guys can see it there. Okay, so we take the whole green graph, translate everything down by 2 units to come up with, to complete the final transformation of downward translation by 2 units. So this graph right here is, in the red, is negative 3/2 times cosine of x minus 2, which is the graph of the resultant function that we come up with.